All right. So hopefully some of you are checking in. I'm going to officially start in about 4 minutes. And then hopefully more people will be here. If you are here, just check in with saying hello. Let me just get this set up. There we go. Thank you. Thank you. Thank you. Excellent. I'm really glad you're here. This will really help with your conclusion and discussion when you do your lab report. And that's going to be a really, really big help for you. All right. So if you remember, your discussion has you answer the 3 questions. Okay. Why do you hear chunk, chunk, chunk when you go over a bridge? All right. Number 2, why do basketballs not work well in the winter? And number 3, why do thermometers go up? All right. And all of those things, if you pay attention, you're dealing with different states of matter, solid, liquid, and gas. Okay. All of those things have different, expand and contract for the same reason. Okay. So as you go through, okay, we'll talk about why that is. So let's just start with the very basics. Okay, effective heat. Now remember, I said that all of these videos, okay, the rest of this unit has to deal with the idea of the kinetic molecular theory. Okay, so someone type in what the kinetic molecular theory says. Go. Oh, come on. Someone hasn't typed it in. Type it in chat. What's the kinetic molecular theory say about heat? When something gets hot, the molecules move. Type it in. The market set, go. Yay! Jenna wins. Okay, Jenna comes in first. She says fast. Connor Mays a little more correct when he says faster. Okay, so when something gets hot, okay, it moves faster. Now, imagine, okay, so these are my molecules. You'll notice, okay, that when they start to move faster, okay, they need more room. Okay, they start to spread out. Same with a liquid, right? If I'm a liquid, as I heat up and as I move faster, I need more room. You'll see, right? Whereas before it was about this big of a space, now it's about this big of a space as it moves around. Gas, same thing. Okay, and it moves around faster and faster and faster and faster. As it moves faster and faster, it needs more room. So I really like to make the connection with you, and these are some of the answers that I'm going to expect. Okay, some of the things I'm going to hear in your conclusion, in your discussion. Okay. So I'll write it down here as a reminder. Okay. So when heat is applied, okay, molecules move faster. When molecules move faster, they need more room. Okay, that is very important. Okay, and then just like the KMT, we can add this line underneath, and vice versa. The opposite is true. When something becomes colder, okay, they start to move. Someone fill it in real quick. When something becomes colder, it starts to move. Write it in, chat, go. Anybody? When something becomes, hey, thanks, Jenna, again with the first. Nice. Okay, so it starts to move slower. Okay, and when it starts to move slower, it's going to need more or less room. Write it in chat. When it starts to move slower, it's going to need more or less room. Write it in chat. Fast, slower, slower. So it's going to need less room. Yes. Who was first on that one? Kaylee was first on that one. Nice. Connor May wrote else room. I'm not sure what that means, Connor. Okay. So it's going to need less room. So as you heat something up, molecules move faster. They need more room. And then the vice versa is true. So let's think about our experiments and then I'll apply it to those discussion questions. And again, because you're here, you'll have a huge advantage when you write your conclusion. In your conclusion, I need to see this. Okay. And then vice versa. And then in your discussion, I'm going to go through those questions. So in your conclusion, okay, going through this, right? Why did the ball not fit in to the ring after I heated it up? Well, because the ball, when it got heated up, this is solid. When the ball got heated up, the molecule started to
expand. We'll go faster.
Go faster. You always start with go faster, okay? Because it started to go faster, okay? Then thanks, Ava. Ava popping in. Slower, less, fast, something. Okay. Then it needs more room. So you picture the molecules in here, right? They're starting to get excited. They need more room. So it doesn't fit in anymore. All right. So that's an explanation of why this works here. Okay. This is your answer to the thermometers as well. Okay. Thermometers don't rise because they get hot. Okay, that's correct, but you're missing a huge step. Okay, when this gets heated, the molecules in the liquid start to move. Type it in, type it in, type it in, type it in before Jacob says it. Go. Faster. Okay. Oh, a little late. Okay, start to move faster. Now they start to move faster and faster and faster. When they start to move faster and faster, they need more room. Okay, hey. Jenna, first again. Okay, they need more room. When they need more room, what's the only direction that they can go? Write it in chat. What's the only direction that they can go? They need more room. They can't expand out of the bottle. So what's the only direction that they can go up? They can go up. Thank you, Connor. Shoot, I gave you the answer, but Connor had it in first. They go up. Okay. So even with my hand warmth, which is kind of cool, I've never done this before. Even with my hand warmth, this thermometer is going up. Okay. This last one is actually kind of cool because it's kind of tricky. Most students get fooled by this. Okay. This is a pulse glass. Okay. What most students will say is that the liquid is heating up, making molecules move faster, and needing more room. And the liquid is going from one side to the other. It's actually the gas. Okay, when I heat this up, the gas, all of this, starts to move faster. Because it moves faster, it needs more room. Because it needs more room, it pushes the liquid. All right, it pushes the liquid. Now, Jacob and I are going to have a contest to see who's got the warmer hands. Okay, so it started about the same. Okay, because the warmer hands will make the gas expand faster. Now, that's really cool about gas. Gas expands and contracts really fast. So I'm warming up my hand. Jacob's warming up his hand. On your mark, get set. Write in who you think will win, Jacob or me. Okay. So who will make the gas expand faster? Okay. On your mark. As soon as we get our first answer, who's going to win, Jacob or me? Okay. Jacob. There's people saying Jacob will. On your mark, get set, go. Oh, let go.
Why?
Jacob wins. Okay. So who knew? Okay. So that's why it works. Okay. So heat makes molecules move faster, need more room, and vice versa. So when I cool something down, when this gets cooled down, the molecules need less room or move slower, need less room, and contract. Okay, so they come closer together. That's an important word, actually. That's a word I'm going to expect in your conclusion. Okay, is the word contract. Okay, and in fact, I'm going to put it here. Okay, I'm going to add 2 vocabulary words. One of the things that I mark is look for is scientific language. So I'm going to needs more room. So we'll call it needs more room and then expand. Okay, that's a word I'll be looking for. And then the vice versa. Okay, so I'll write the vice versa in blue. I don't think it necessarily shows up, but cool, slower, less, contract. Okay, so those are some of the things I'm looking for in your conclusion. So in your conclusion, explain just these three things. Okay, actually, it might be easier with the gas one to use this. Okay, so when I heated up this, right, the gas particles started moving faster. Okay, because it started moving faster, we need more room, and because that, the balloon expanded. Okay, liquid thermometer. Let's use contract just because as it cooled, the molecules moved slower. Because it moved slower, okay, they needed less room, and it contracted. The thermometer went down. All right, this one, okay, I don't think you can cool it. Actually, it'd be kind of cool to see. I don't have an ice pack.
I tried it upside down.
Okay, gas expands. Okay, heats up, moves faster. Okay, this one, as it cools, it contracts. Okay, molecule moves slower, needs less room, contracts, and is able to fit through the ring again. Now, so what does that have to do with the three questions? Okay, well, let's think about this together. I'm going to see if we can fill some blanks. Okay, why do you hear chunk, chunk, chunk when you go over a bridge? Okay, picture the Skyway. Okay, and I'm pointing in the direction of the Skyway over there. And picture the Skyway. Why do they have? I'm going to see if someone can type in the correct answer. Why do you hear chunk, chunk, chunk when you go over? I'll give you a similar hint. Same reason why when you're skateboarding, you hear chunk, chunk, chunk on the sidewalk. What do they both have in common? Someone type it in. 5, 4, 3, 2, 1. Oh, both of those are not quite there yet.
Cracks.
They both have cracks. Okay, they both have cracks. Okay, so the sidewalk has cracks and the bridge has cracks in it. And those people put those in on purpose. Okay, the reason why those cracks are there, okay, is to give them room. Exactly, Hannah, to give it room to expand and contract. So in the summer, when your sidewalk outside your house gets hot, okay, then the sidewalk, okay, you can picture it like this, the sidewalk can expand and come together. Okay, without breaking. Because if it didn't, if your sidewalk didn't have those cracks in it, when it got hot or when the bridge got hot and it didn't have those expansion joints, that's what those are called, then your bridge would crack, right? It would try to expand, it would go poof, right? And it would break. Okay. So that's why you hear crack, crack, or chunk, chunk, chunk when you go over a bridge, and why they put cracks in your sidewalk. It's the same reason if you look at the siding of your house. Here's a weird thing that I learned from Mr. Vermeulen. That if you put siding on your house, they don't put it end to end and lock it in, because in the summer, when the side of your house starts to get heated up, those sidings expand, and if they expand too much, you'll see waves. So if you look at the siding of your house, if you see waves, it's because they didn't factor in the fact that it was going to expand. In our school, I wish normally at this point I'd take you on a tour of the school, because we can look around the school and look for all the things that they put in place, because our entire school contracts and expands because of heat. So in the summer, when it expands, okay, you've got rubber joists. It's not a great example, but if you look at the front of the school, right underneath the grade 8 classroom, you've got these huge, long rubber joints, and they're put there so that the school can contract and expand. At night, and Kayla, for some reason, you're watching a lot of psychic and scary videos, haunted videos, okay? Your house may crack. You may hear your house cracking at night. And the reason why you hear your house cracking at night is because your house is actually contracting. It expanded during the day, and at night it goes cuckoo, 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 right? And that's the sounds that you hear. We have a hot water radiator in our home, and when our hot water radiator here goes on and the heat starts going through our radiators, all right, you'll hear it pop. Okay, and that's because everything is expanding. Okay, and as it expands, it makes those pops. All right, so those are all things, solids that expand. In a liquid, I've already talked about this, so I'm not going to take it too long. okay, liquids go up, okay, in a thermometer because there's no more room. Okay, it can't expand in the bulb at the bottom. Okay, if Jacob grabs me a thermometer from over there.
This.
No, a thermometer, not a holder.
Oh.
Okay, a thermometer. Okay, as this heats up, okay, so Jacob's put his hand on it and see if he can make it go
This?
up. Okay, actually, this is a bad thermometer because it doesn't work very
Okay.
well. Okay, it goes up because the liquid molecules, the
This?
alcohol thermometers, okay, heat up, molecules move faster, they need more room, okay, and it expands. Okay, this is not a bad one. So it starts at 24, okay, and Jacob's going to try to make it go up, okay, because it can't expand down here, so it expands up. Thermometers is fairly straightforward. We've
Put it
talked about
down,
that a couple
put it down.
times, okay. Gases. So why does your basketball? And we just took out our bikes from our shed. When after this in the spring, when you take your bikes, the first thing you have to do is pump up your tires. Well, the reason why, okay, in winter, the gas in your tires are going to heat or cool. Write it down. The gas in your tires are going to heat or cool in the winter. And you can apply this to your basketball. It's going to cool. Okay. And because it cools down, okay, because it cools down, the molecules are going to move faster or slower. Awesome. Going to move faster or slower. So the molecules in your basketball, okay. Good. Ava, first with the slower. Okay. So it's going to move slower. All right. It's going to move slower and slower and slower. Now, when it moves slower, okay, the gas, okay, the basketball or your tires, okay, the gas is going to need more room or less room. Jacob?
More. Yes.
He's going to need less room. Okay, because it needs less room, the gas that makes your basketball bounce starts to expand or contract. So the gas in your basketball, because it needs less room, the gas in your basketball is going to expand or contract. Ah, Jenna, first with the contract. Okay, nice. So it's going to start to contract. Okay, and because it's contracting, there's not as much bounce, and that's why you have to fill it up. So so in your discussion, you're going to need to answer all three questions. All right. Why do basketballs not bounce well in the winter? Why do you have crack? Why do you hear chunk, chunk, chunk when you go over a bridge? You have to mention expansion joints. And then why do thermometers go up? You can't say they go up because it gets hot. You have to put all these things together. It gets hot, so the molecules move faster, so it needs more room, and then it expands. Any questions? Any questions? I'm trying to think of where else you see this. Because you see it all the time. One of my goals when I teach science is to say, hey, right? You see this all the time. The effect of heat.
When you do this.
And some of it's really obvious, something like this. Okay, but some of you may go, oh, now I know why. For example, you hear the house contracting at night. Okay, why the siding on your house might be bubbly. I'm trying to think of any more examples. Why there's joints in your wall. Okay, you may see that. I can't think of anything else that you see for gases, although a really cool one, and I showed that. Oh, you'll learn about thermometers. Thermometers, any kind of thermometer, uses this idea that things expand and contract. So your lesson on Friday, is on Friday? Your lesson on Friday is on thermometers?
Yeah.
Your lesson on Friday is on thermometers. Okay, and I had to change that to Google Slides. Riley, thank you for pointing that out. So I made that different. And it's on thermometers. And thermometers all work on this idea that things expand in the winter, or expand in the summer, and contract in the winter. All right. I don't know if there's any more questions.
This goes up like fast.
Great question, Connor. So Connor's asking, do we have to explain each experiment? I would say explain this one, and this one. Don't try to explain all of them.
Is this
Okay.
supposed to be a thermometer?
Yeah, this is the thermometer. Okay, so explain why the liquid in the flask went up and down. Explain why the ball did or didn't fit in the ring, and explain why the balloon expanded or contracted. Okay, great question.
Is this
All right.
supposed to look like fire?
Any other questions? I did return your KMT labs. I gave you an opportunity to correct them. Lots of I reminded you to correct them, right? Some of you handed them back without making the adjustments that I suggested. So I had to give you a mark as is. I'm hoping that you'll take this lesson and apply it to your the effective heat lab. Okay, as you go through it and pay attention to some of the things. I'll give you a chance again, right? I'll go through your effective heat lab. I'll make any suggestions, and your job is to incorporate those two suggestions and then rehand it in for marks. All right. Connor, that was a great question. Any other questions? Make sure you do the pop quiz if you haven't done that yet. And you can hand in this lab as soon as you can. Thank you so much for participating. I'm glad to see 10 of you were here today and
10.
2 thumbs up. Awesome. You don't have to subscribe. All right.